All right, today we will learn how to use the quadratic formula to solve quadratic equations. Quadratic equations are equations that have a variable that is squared, such as x squared. I have the quadratic formula here to the right, and before you can even use it, your equation must equal 0. So this formula works for quadratic equations, but it must equal 0. If it does not equal 0, you need to move everything to one side. So looking at the example I have here, we have ax squared plus bx plus c. A, b, and c represent a number. So the steps are, first you would need to make your equation equal 0. Once that has happened, then write it in what we call standard form. Standard form looks like this, where the x squared portion comes first, then the x, and then the c, and then it equals 0. Once you have that, a will be the number in front of your x squared, b will be the number in front of your x, and c will be the last number. Let's go ahead and do some examples. So here's an example of a quadratic equation. This equation is already in standard form, and I know that because I see x squared, x, and I see the number at the end. It also equals 0. Once that happens, you need to start listing what a is. A is the number in front of x squared, which is 2. B is the number in front of your x, which is a -5. And c is that last number, which is 3. Now, the next step is you would need to plug these into your equation right here. So I have x equals negative b. B is a -5, so we're going to have a double negative here. Plus or minus the square root of b squared. B squared is -5 squared. Minus 4 times your a, which is 2. And times c, which is 3. And this is all going to be over 2 times your a. So you need to go through and plug in your a, your b, and your c. Next, I just need to simplify this. When you have two negatives, that will turn into a positive. So this is going to be a +5 plus or minus. Okay, I got a little line there I needed to erase. The square root of, now if you are allowed to use a TI-84 or a calculator, I would go ahead and enter -5 squared minus 4 times 2 times 3 to cut down on your time, but I'll go ahead and do the steps here. -5 squared is 25 minus 4 times 2 times 3. 4 times 2 is 8. 8 times 3 is 24. Next, I need to simplify what is under my square root. 25 minus 24 is 1. This is all over 4. All right, now we need to get the square root of 1. The square root of 1 is 1. 1 times 1 is 1. And I have no more square root left, so I can go ahead and split this up. Separate the plus and the minus. One equation will be 5 plus 1 over 4. And the other equation will be x equals 5 minus 1 over 4. Now I would just need to simplify this. 5 plus 1 is 6 over 4. This will simplify by 2, or you could just use your calculator to get 3 over 2. So one of your answers will be 3 over 2. The other answer would be 5 minus 1 is 1. 5 minus 1 is 4 over 4. 4 divided by 4 is 1. So your answer to this equation will be 3 over 2 and 1. That's not an ordered pair, by the way. It's just how your answer is. All right, let's do another example. So we have 2x squared equals 1 minus 2x. These are not on the same side, so I can either move the 2x squared this way or I can move these to this side. Both ways would be correct, but I would like to keep the x squared as a positive so that I don't have to simplify the negative in the denominator in the end. So I will move the 1 to that side. Since it's crossing over the equal sign, you would need to change its sign. So I'll need to subtract 1, and I'm going to go ahead and put a minus 1 here. And I would also need to move this negative 2x, which we would add. And I'll just kind of stick it here. So now we have 2x squared. You want to put it in order. The x part goes next, so that's plus 2x. And then the other part, which is a minus 1, equals 0. All of this side will cancel. That's why it equals 0. Now I'm ready to say what a, b, and c are. So my equation will be x equals negative b, which is 2, plus or minus the square root of 2 squared, minus 4 times my a times my c, and this is all over 2 times your a. I will continue to simplify under the square root. So 2 squared is 4. This is a negative 1. 4 times 2 times negative 1. 4 times 2 is 8. 8 times negative 1 is negative 8. Or I could say this is the same thing as saying negative 4 times 2, which is a negative 8. Negative 8 times negative 1 is a positive. So if I had kept this as 4 times 2 times 1, that's a negative 8, but then there's a minus there. So that is how I know this is going to be a plus. If you ever see a negative and we're multiplying, it's going to end up being a plus. And this is all over 4. Now I need to add 4 and 8 to get 12. Now 12 is not something that you can get a perfect square root of, so you just need to simplify the square root. I think the easiest way to do that is doing a tree diagram on this 12. 12 is the same thing as saying 2 times 6. 6 is 2 times 3. So you break it down all the way. Circle each pair. I have a set of 2 here. That would come out. And I have a 3 left. This 6 does not count because I already broke it down. So that 3 that did not have a pair goes back inside. So the square root of 12 is the same thing as saying 2 square root of 3. So now I have 2 plus or minus 2 square root of 3 over 4. So there's different ways you can do this to simplify. I could go ahead and split up my plus or minus here, which I think is what I will do. But I'm going to put each part over 4. So I have 2 over 4 plus 2 square root of 3 over 4. That's one of my answers. And the other one with the minus, oh, and it's not 2, it's negative 2. Don't know, I forgot my negative. So negative 2 over 4 plus, no, minus, because I already got my plus, 2 square root of 3 over 4. Now I need to simplify 2 and 4. 2 and 4 is the same thing as saying 1/2 because I could divide these by 2 to simplify. So my first answer will be negative 1 over 2 plus, I can also simplify this 2 as long as it's outside the square root on the 4 to get 1/2. But since I have a square root of 3 there, we don't write 1 square root of 3, just write square root of 3 over 2. This is one of my answers. The minus 1 will be the exact same thing except this is a minus. So this is my second answer. Okay, let's do a few more examples. All right. Okay, just bear with me here. I'm trying to get it to be big so I can erase it quickly. But I don't want to erase the formula on the side. So I just have to be a little bit careful there. Okay, now I'm going to do another example. This is our example 3. All right, so for this one, it does not equal 0. So first I would need to move the 5 to this side since my x squared is positive already. Then I can write what A, B, and C are. A is 9, B is 8. Remember, it's the numbers in front, and C is -5. Remember to make sure it's in standard form. So x equals -b, which is 8, plus or minus the square root of b squared, that is 8 squared, minus 4 times my a, which is 9, times my c, which is a -5. And this is all going to be over 2 times your a. Again, now once you plug those in, you just need to simplify this. 8 squared is 64. I see a double negative. I already know that is going to be a positive. So now you would need to do, and I would recommend using your calculator again, especially if you are allowed to use it. So if you're using your calculator, you would do -4 times 9 times -5. And that is 180 over 18. Next, you'll add 64 and 180. To get 244. All right, I need to break down 244 because it's not a perfect square root, and you can tell that because if you try to get the square root of it, you will see that it is a decimal. All right, so I think the easiest way is just to go by 2 until I can't. 2 goes into all even numbers, so that's 122. 2 can still go. That is 61. Now check if you can do 3. I don't think I can go any farther than that, but because it doesn't go into 3, it will not go into 4 since it didn't go into 2, 5, 6, 7. 61 is a prime number, so this is as far as I can go. So that is what comes outside, and the 61 will stay inside. So now I have x equals -8 plus or minus 2 square root of 61 over 18. So x equals -8 over 18 plus 2 square root of 61 over 18. And x equals -8 over 18 minus 2 square root of 61 over 18. So I just need to simplify these fractions. I see 2 goes into both of these. That's 4 and 9. So x equals -4 over 9 plus, yeah, 2 goes into 18. If I'm simplifying 2 and 18, that is not 9. Because look, if you do it like this, that becomes 1 over 9. But since you never want to write this, there's an understood one there. So you're just going to put square root of 61 over 9. This is my first answer. And the other one, again, will be exactly the same, except you will have a minus. By the way, you could also write this like this. So x equals -4 plus or minus square root of 61 over 9. This is still the same answer. All right, let's see. Let's do one more example. Get my little eraser here. But the concept of solving these is the same. You just need to first put it in standard form, put your equation in standard form, and then you would go from there. All right, the next one I have is, I think this is example 4. Okay, so this one is already in standard form. So you can go ahead and simplify, or we break it down. A is 9, B is -6, and C is 1. So x will equal negative b, so that's a -6 plus or minus the square root of b squared minus 4 times your a times your c all over 2 times your a. Remember, a double negative makes that a positive. This is 36 minus 4 times 9 is also 36. So x becomes 6 over 18 plus or minus square root of 36 minus 36 is 0. All right. So what is the square root of 0? Square root of 0 is 0. So really this whole part can go away, including the plus and the minus. So all I have left is 6 over 18. You can only do that with the 0, which I can simplify this to get 1/3. So this one will only have one answer, which is 1/3. Okay, that is how we solve using the quadratic formula. In this lesson, you will learn how to solve quadratic equations by factoring. To solve quadratic equations by factoring, your equation must equal 0. So you need to have all the terms on one side and make your equation equal 0, and then you'll factor and split up the terms and solve. Let's go ahead and get started. For number 1, it already equals 0. So I just need to factor this. First, you always look for the greatest common factor, which here I can take out a -3. I'm taking out a negative because this first term is negative. So -3x squared divided by -3 is x squared. 75 divided by -3 is -25 equals 0. Now I can factor this. So we have -3. This is a difference of two squares. You just get the square root, and one will be plus and one will be minus. So square root of x squared is x, square root of 25 is 5. So x minus 5 and x plus 5 equals 0. Now I need to split up this term. So before I do that, I can divide by this -3 because it does not have a variable. So I'll still get 0. Okay, so now I'm ready to split this up. So you'll have your first equation as x minus 5 equals 0, and your second equation as x plus 5 equals 0. This one I would add 5, and this one you would subtract 5. So for the first equation, you will get x equals 5, and the second one, x equals -5. Okay. For number 2, I need to either bring these to the right or these to the left. It's probably easier to bring these two to the other side, so let's go ahead and do that. So subtract 3x squared, subtract 3x squared, add 20x, and add 20x. So on this side, I know I'll have 0. -4 minus 3 is -7x squared minus, no, it's going to be a plus. -7 plus 20 would be plus 13x, and then minus 6. If your first term is negative here, especially with that trinomial, let's go ahead and divide everything by -1. And all that will do is change all your signs. It will make it so much easier for you to find your product and sum. So we have 0 equals 7x squared minus 13x plus 6. This is a trinomial. First, I would look for a greatest common factor, which I do not have one. Next, I need to do my product and sum. So you're looking for two numbers that would multiply to get 42. And then the sum is -13. So I know 7 times 6 is 42. 7 plus 6 is 13, but I need it to be negative. So I also know -7 plus -6 is 42. -7 plus -6 is -13. If you need to review solving trinomial equations where a is greater than 1, go ahead and do that. Now you would take this and replace the middle term. So I have 0 equals 7x squared. You always want to group these with the one you would have a common factor with. So I'm going to bring this 7 first, then minus 6x plus 6. Now we are going to group factor. Here I can take out 7x as a greatest common factor. 7x squared divided by 7x is x. Negative 7x divided by 7x is a positive, no, it's a negative 1. Here, because this is negative, I need to take out a negative, and I can take out a negative 6. Divide that, you will get x. 6 divided by negative 6 is negative 1. These have to be the same for you to move on. So since it's the same, it's our common factor, and then you write what's left, which is 7x minus 6. Now I'm ready to split these up and solve. So I have x minus 1 equals 0, and I'll write this one here because I need more room. 7x minus 6 equals 0. For this one, I just need to add 1 to get x equals 1 as one of my answers. For this one, you would need to add 6. So 7x equals 6, and then divide by 7. So x will be 6 over 7. Okay, number 3, again, I need this to equal 0. So I don't want my y squared to be negative, so let's go ahead and move the 9y to the other side. It's just going to go right here because those are not like terms. You just write out 6y squared minus 9y. They're not like terms because this one's squared and this one's not. Now I can do greatest common factor. Let's draw a line here. So I can take out a 3y because they both have a y. 6 divided by 3 is 2. Y squared divided by y is y. Minus 9y divided by 3y is 3. Now go ahead and split this up. So I have 0 equals 3y. And 2y minus 3 equals 0. For this one, just divide by 3, and you'll get y 0 as one of your answers. For this one, add 3 on both sides to get 2y equals 3, and then divide by 2. I try to put in a lot of examples because I know these can be a little bit difficult. All right, number 4, it already equals 0, so I just need to do factoring here. I have a greatest common factor, which is x, so take out an x. Divide everything by x. You're going to have 1 less x on each term. So this is a trinomial, okay? Bring down the x, and it is a is 1, so I can go ahead and find my numbers and plug those in. So product is 49, and the sum is negative 14. That is negative 7 and negative 7. Negative 7 plus negative 7 is negative 14. Negative 7 times negative 7 is 49. Now we're ready to solve this. So here I have x equals 0. That's already solved. You have to split up each term. Then here I have x minus 7 equals 0. This is the same thing, so you don't need to write it twice. So just add 7, and here you'll get x is 7. So 7 and 0 are your answers. For my last problem, it does not equal 0. So first subtract 24 and to bring it to this side. So I have x squared minus 5x minus 24 equals 0. This is a trinomial where a is not 1. So I know I'm going to go ahead and set it up like this. So you're looking for two numbers whose product is negative 24, and the same two numbers must add up to negative 5. That is negative 8 and positive 3. So then just solve them. Split them up. So here you're going to add 8. Here you're going to subtract 3 on both sides. So you will get x equals 8 and x equals negative 3. That is how you solve quadratic equations by factoring. In this lesson, you will learn how to use the square root method to solve quadratic equations. Remember that a quadratic equation is just an equation that's in the form of ax squared plus bx plus c. In other words, if it has an x squared, then it's a quadratic equation. So let's go ahead and get started. With the square root method, it only works with certain quadratic equations. It works if the middle term bx is missing. So if there's no x term, it has to have an x squared because it's a quadratic, but it does not need to have the bx term. That would be like number 1, 2, and 3. The other way that it works really well is if you have like number 4 here, you have parentheses and then you have a squared. It's gonna work for number 4, number 5, and number 6. Let me go ahead and get started with the example so that you can understand it. For number 1, okay, so the goal of all these is to get the x squared by itself. Once you get the x squared by itself, you can get the square root of both sides and then you solve. So get the x squared by itself, square root, and solve. That's what we're going to be doing. So for number 1, the x squared is already by itself, so I can get the square root of this side and the square root of that side. I'm getting the square root because the square root is the opposite of a squared, so they essentially cancel out, and all I have here is x. What is the square root of 64? You may know that to be 8, but when you're solving, it's going to be plus or minus 8, or in other words, it's going to be a positive 8 and a negative 8, because 8 times 8 is 64, and also negative 8 times negative 8 is 64. So since I have the x by itself, I am done. My answer for number 1 will be 8 and negative 8. For number 2, the squared x squared is not by itself. So first I need to move this 4 to the other side. Remember, the opposite of addition is subtraction. So subtract 4, that's going to cancel. So now I have x squared equals 0 minus 4 is negative 4. Now the x squared is by itself, I can go ahead and get the square root, So I finally have my x. What is the square root of negative 4? That is actually not a real number. So it's what we call an imaginary number, which we don't cover in this course, but it is covered in my master course. So when you run into where you're getting the square root of a negative, you are going to say it's an empty set or no solution, because there's no square root of negative 4 that is real. All right, moving on to number 3. Here I'm going to add 10 to get that x squared by itself. So I have 2x squared. The 10s cancel, so here I have equals 10. Divide by 2. So I have x squared equals 5. Finally, I'm ready to get the square root. Square root of 5 is simplified. So for number 2, that's as far as you can go. I'm going to get x equals plus or minus square root of 5. This will be my answer. I tried to squeeze in as many examples as I can on the board so that you can see different types of scenarios of how to work this out. So just bear with me on the space. Number 4, I have parentheses, x minus 5 squared equals 49. So when you have parentheses, you just want to make sure the part that is squared, which is what's in your parentheses, is isolated all by itself, which it is for number 4. So now I need to get rid of this squared so that I can get this x out. So I'm going to get the square root of this side, and I'm going to get the square root of that side. That's going to cancel. Here I have x minus 5 equals square root of 49. Remember to always do your plus or minus, because when you're solving, it will apply to positive and negative. If I would have been done with just x here, I would have said the answer is plus or minus 7, but I need to bring the negative 5 to the other side. I recommend you split up this into 2 equations. So you have x minus 5 equals your positive 7. X minus 5 equals negative 7. So I just split up my plus or minus 7 so that it's easier to solve. So now opposite of subtraction is addition, so add 5 to both sides. I get x equals 12. Add 5 to the other equation, and you get x equals negative 2. So this is an answer, and that's an answer. Okay, number 5. So here's my squared. The negative 32 is not part of it, so it has to go to the other side. So add 32 to both sides. So I have 3y minus 7 squared equals 32. Now I'm ready to get my square root on this side, get my square root on that side. That's going to cancel. So I have, I guess I'll write that here, 3y minus 7 equals plus or minus the square root of 32. The square root of 32 is actually not a perfect square, but you need to simplify this. I don't know if you remember how to do that, but I'll go ahead and do it. How I do it is, I think it's easiest to just do a tree. What times what is 32? I would say 16 times 2. You could say 8 times 4. It really doesn't matter. Then here I have 16. That's 8 times 2. You have 2 times 4 and 2 times 2. When you're doing a square root simplification, any two numbers that are the same go in a circle. I could pick any two numbers. So I see 2 2s, that's one set. I see another set. The sets come outside. So I have a set of 2 and a set of 2. So that would be 2 times 2, which is 4. On the inside is whatever's left. If you have more than one number that's left, you multiply them. This is the only thing I see left, so that's a 2. So square root of 32 simplifies the same thing as saying 4 square root of 2. So I'm going to come here and say that. Next, I need to continue solving for y. So I'm going to add 7. I'm not going to split this up. You can, but I'm not going to do that just because I already see you can't really add this to the 7. We're just simplifying as much as we can. You do want to put the 7 in front of the plus or minus though. So here I have 3y equals 7 plus or minus 4 square root of 2. Divide by 3, divide by 3. Here I have y equals 7 plus or minus 4 square root of 2 over 3. If you could have simplified this, you would need to do that. So I think I'm going to show you an example of what I mean at the end. Let me go ahead and work on number 6, but I'm going to show you how you may turn into a situation where you can simplify this, but you can't simplify this one right now. So we're going to stop. Okay, number 6, this is already by itself. I thought it would be good to throw in a fraction in there because I know a lot of people don't like fractions. So go ahead and get the square root of this side, get the square root of this side. On that side, that will cancel. Here I have m plus 1/3 equals plus or minus square root of 1 over 9. The best way to do this is get the square root of the numerator, which is the top, and get the square root of the denominator. Square root of 1 is 1. Square root of 9 is 3. Now, because the squared part is gone, is when I'm going to split this up. So I have m plus 1/3 equals a positive 1/3. And then I have m plus 1/3 equals a negative 1/3. So subtract 1/3, subtract 1/3. So I have m equals 1/3 minus 1/3. I'm subtracting the same thing, so that's just 0. Here, I'm going to do the same thing, subtract 1/3, subtract 1/3. So I have m equals negative 1/3 minus 1/3. Remember, you just need your denominator to be the same, and then you can go ahead and combine the numerator. So since my denominator is the same, I don't even have to worry about that. So you do negative 1 minus 1, which is negative 2, and you keep your denominator the same. So the answer here would be negative 2/3 and also 0. So now come back to this one. I want to do an example of, say we've simplified an equation and then we get something like x equals 6 plus or minus 4 square root of 3 over 12. You can only simplify this if you have a common factor between the 6, the outside number, never the inside of the square root. Think of it like it's blocked in there, and the denominator. If there's a number you can divide by all of those, you want to go ahead and do that. So for this one, I know I can divide all of them by 2. So 6 divided by 2 is 3 plus or minus 4 divided by 2 is 2. Square root of 3 over 12 divided by 2 is 6. I know I cover this in completing the square and also in the quadratic formula video. So just watch on and you'll be able to understand this a little bit more. But I just thought it would be nice for me to touch on it. And that is how we solve quadratic equations using the square root method. In this lesson, we will learn about the discriminant. The discriminant is used to tell us how many solutions we can find in a quadratic equation. Remember that a quadratic equation is just an equation in the form of ax squared plus bx plus c. So if you see x squared, then it's a quadratic equation. The discriminant is really important because it tells us what type of solution you expect. So by that I mean, is it real or is it not real? It also tells us how many solutions. Is it 1 or is it 2? You can really use this to check yourself when you're solving using one of the other methods we've learned before. The discriminant formula is actually found in the quadratic formula. It's under that square root part. It is b squared minus 4ac, where a is the number in front of the x squared, b is the number in front of the bx, and c is the constant. It does not have a variable next to it. So all you have to do is, number one, you need to write your equation in standard form. That means it has to go in order from x squared to x to the number and then make it equal 0. So you want everything to be on the same side. So they need to be either on the left or on the right, and then x squared, x, and the number. Second, write down what is a, what is b, what is c. After you do that, you just plug them into the formula and simplify. After you simplify, this is how you will know. If your answer is negative, you are going to have two non-real solutions. If your answer is positive, you are going to have two real solutions. If your answer is neither positive nor negative, which means that it's 0, you will only have one real solution. It doesn't tell you what the solution is, it just tells you what to expect. Let's do some examples. So for number 1, I have this quadratic equation. I see an x squared. First, I want it all to equal 0, everything to the same side. So what I'm going to do is move this negative 9 to the other side. So since it's a negative, I'm going to add 9x squared, bring it to the front because it goes from x squared, so it can be in standard form. So I have 9x squared. I don't need to put a plus there because it's first. And then I'm just going to drop these down. Here, that's gone, so I have 0. So that's good. Now I know that a is the number in front of x squared, which is 9. B is the number in front of x, which is a negative 6. And then c is that last number, which is 1. So I'm ready to go to my formula, which is b squared minus 4ac. I guess I'll go ahead and write it down. B is negative 6. It's really important you put this in parentheses. The b goes in the parentheses, which is a negative 6, and that's squared, minus 4 times a, which is 9, times c, which is 1. You can either put parentheses here or you can just put times. So how do we simplify this? Remember that the order of operations says that the negative 6, the exponent part, must be done first. So negative 6 squared is negative 6 times negative 6, which is a positive 36. I'll just drop this down because I don't like to do things all at once. Drop your 36 and multiply. So negative 4 times 9 is negative 36, times 1 is a negative 36, so I have minus 36. 36 minus 36 is 0. That's not the answer. This tells you that that's 0. When the answer is 0, how many solutions can you expect? One real solution. So if you're solving this, I should just get one answer, not two. All right, on to number 2. Move the 7 to the other side, so subtract 7. So I have 2x squared minus 7 equals 0. Now it's in standard form. A is the number in front of x squared, which is 2. B is the number in front of x. I don't see an x, so you're going to make that 0. And then c is that last number, which you have to get the sign in front of it too. So that's a negative 7. I am ready to plug these into my formula, which is b squared. B is 0, so 0 squared minus 4 times a, which is 2, times c, which is a negative 7. Again, exponents go first. 0 times 0 is just 0. I'm just going to go ahead and drop these down. Then multiply these. So I'm dropping down my 0. Negative 4 times 2, negative 8. Negative 8 times negative 7 is a positive 56. Add these two, you get 56. So this is a positive answer. Because it's positive, I know I'm going to expect two real solutions. So the problem would say something like, use the discriminant to determine how many solutions on what type. So this is how you do it. All right, finally this one. I could either move my 3x squared to this side or move these two to the, it really doesn't matter. Let's just move the 3x squared because it seems easier. Just remember to put it in the front. So 0 equals negative 3x squared. 9 is positive, so plus 9x minus 7. If I moved these to the other side, I would get different signs, but it would all work out when we do the simple math. So here I have a is negative 3, b is 9, and c is negative 7. So I'm ready now. b squared, so b is 9, minus 4 times a, which is a negative 3, times c, which is a negative 7. So 9 times 9 is 81. Drop these down. 81, multiply these now. I have 3 negatives, so I know it's going to be a negative, but negative 4 times negative 3 is negative 12. No, it's positive 12. Negative and negative is a positive. So positive 12 times negative 7 is a negative 84. Now we can subtract 81 minus 84 is going to be a negative 3. Because it's negative, I know I can expect to have two non-real solutions. And this is how we use the discriminant to determine the solutions in a quadratic equation. In this lesson, you will learn how to evaluate or simplify complex numbers. Complex numbers come when you have a square root of a negative number. So the square root of 9, for example, is 3 because 3 times 3 is 9. But what if I wanted to find the square root of negative 9? This, in fact, is not a real number because there's no way you can have, if I have 3 times negative 3, that is a negative 9. But the definition of a square root is you have to multiply the same number twice. So it's either 3 times 3 or it's negative 3 times negative 3, and neither will be 9. So this is where the complex number, which is called I is an imaginary number, comes in. So the square root of negative 9 would be, you would go ahead and get the square root of 9, which is 3, but then add the I. So it just says that it's an imaginary number, so 3I. I squared will equal negative 1. This is important that you need to know. So to check this, if I was doing 3I times 3I, this is 3 times 3 is 9 times I squared. And remember, I squared is negative 1, right? So look, we get negative 9. So that is where the complex number comes in. Or if I have the square root of negative 144, I would just get the square root of 144, which is 12, and add an I. So even if you have the square root of something that's not a perfect square root, like negative 44. So what I would do here is simplify 44, which is 4 times 11, and then that's 2 times 2. If you have a pair, it comes outside, and that number that's left goes back inside. But since it was a negative, the I would come right there next to the 2 outside of the. So in other words, you could even say this negative part is an I, and then keep the 44 like that. So now we're going to learn how to add and subtract, multiply, and divide. So we'll start with adding and subtracting. When adding and subtracting, you treat the I like you would a variable like x. Follow those same principles to simplify. Let me go ahead and put up some examples so you can follow. Okay, so let's say I wanted to do what is 2 minus 3i plus 6 plus 8i. And you'll often see it written as, put your answer in the form of a plus bi. A is the real number part that does not have an I. The bi is the other part that has an I. So you have to put it in that order. If you have a plus, I can ignore these parentheses. So this is the same thing as saying 2 minus 3i plus 6 plus 8i. Combine your like terms. So 2 and 6 do not have a letter, so they're like terms. 2 plus 6 is 8. And then negative 3i plus 8i is negative 5i. So this becomes your final answer. I cannot combine this because one is imaginary and one is real. All right, let's do another example for addition. And then we'll do subtraction. So again, ignore your parentheses and just drop exactly what is in there without those parentheses. Now I would combine my like terms. So 4 plus negative 8 is a negative 4. And then the 5i plus 2i, which is 7i. Oh, that's supposed to be a negative. So that's my answer. What happens when we subtract? When you subtract polynomials or even these complex numbers, you need to change the subtraction to addition and change the signs of the terms you are subtracting. That is the terms that will be in the parentheses after the subtraction sign. It's really basically because you are distributing your negative. All right, let's go ahead and do some examples. So let's say I have negative 3 plus 2i minus 4 minus 4i. So I want this subtraction here to become addition. Uh-oh, thought I changed the color. Okay, you want this to become addition. If I change that, I must change this sign. You see how it's a positive? Now it becomes a negative. If this is a negative or minus, now it becomes a plus. So after you do that, now I would just go ahead and drop, as long as it's a plus here, you can drop your parentheses. And drop the signs in front of what you're seeing. So now I need to combine negative 3 minus 4, or you can say plus negative 4, that's negative 7. And then 2i plus 4i is 6i. All right, let's do another example. So again, I see a minus here, so I'm going to change that to addition. If I change that, I change this one. Since it's a negative, now it becomes a positive. Change this one. Since it's a negative, now it becomes a positive. And so let's drop the parentheses and say what's left. See how it says plus plus? I'm just going to put what's on this, and I could have done that up here as well. So to combine my like terms, I have 3 plus 3, which is 6. Negative 4i plus 4i is 0. So I could just write 6, or I could write 6 plus 0i, especially if it tells you to put it in this form. Okay, so remember, when you're adding, you just drop it. When you're subtracting, change your subtraction to addition and change those signs. You never change the signs of these first parentheses, only the one after you're subtracting. Okay, so now let's go ahead and do multiplication. You are going to follow the same rules as you would multiply polynomials or x's and y's, except when you see I squared, you must replace that with a negative 1. Okay, so multiply the same way, except when you see I squared, replace it with a negative 1. So for multiplying complex numbers, let's say I have a 3, I'll just call this example 1, and you also want to write it in standard form. So I know here I'm multiplying because there is no sign between the 3 and the 2, so that is the same thing as multiplication. I'm going to use the distributive property here, where you will say 3 times 2 is 6, 3 times negative 6i is negative 18i. So I don't have an I squared there, so I'm good to go. All right, let's do another example. Here, I'm going to do more than distribute. You can either use what we call FOIL, which all FOIL is distributing. So I'm going to ignore this minus 4i here and start with 3. Distribute the 3 by multiplying it here. So 3 times 2 is 6. 3 times I is 3i. And then do the same thing. Now you're done with the 3. Do the same thing with the negative 4i. Negative 4i times 2 is negative 8i, and it helps you when you draw these arrows. Negative 4i times I is negative 4. Since we're multiplying two i's, that becomes I squared. Okay, now I need to combine these like terms. 3 minus 8 is negative 5i. Here I have an I squared, so it's going to be minus 4 times I squared, which is a negative 1. All right, next I have 6 minus 5i. Negative 4 times negative I is a positive 4. And finally, combine 6 and 4 to get 10 minus 5i. All right, now that was a lot of steps, so let's do another example. All right, so here, again, I'm going to distribute this first. Negative 3 times negative 3 is a positive 9. Negative 3 times negative I is a positive. Negative and negative is positive, 3i. Now I will do this. I times negative 3 is negative 3i. And then finally, I times negative I is negative I squared. Combine your like terms, which will often be right here. 3 minus 3 cancels out. That's 0, so I really don't have to do that. Minus I squared. So I squared is negative 1. Now I just have to do 9 minus negative 1, and that is equal to 10. What if I have that? So 3 minus 2i squared is the same thing as saying 3 minus 2i times 3 minus 2i. Now you are going to do the same thing. So 3 times 3 is 9. 3 times negative 2i is negative 6i. Negative 2i times 3 is negative 6i. And finally, negative 2i times negative 2 is a positive 4i squared. Combine your like terms. This does not cancel out. Negative 6 minus 6 is negative 12i. Plus 4 times negative 1. 4 times negative 1 is negative 4. And finally, combine the 9 and the 4. 9 minus 4 is 5. And that becomes my final answer. So that is how we multiply complex numbers. So now we've done adding, subtracting, multiplying, and dividing. Adding, subtracting, and multiplying, I'm sorry. Next we will do dividing. All right, so dividing complex numbers. The main thing with this is you do not want an I in the denominator. We are going to use what we call the conjugate to make it to where there is no I in the denominator. So what does that mean? Okay, a conjugate is this. Let's say you're adding or subtracting. A conjugate is the same term. Okay, like let's say I have 4 plus I. I erase this a little bit. So the conjugate of 4 plus I, you keep everything the same but change that middle term. So these are conjugates. Another example is negative 2 plus 3i would be negative 2 minus 3i. Those are conjugates. So whenever you have a binomial, which is 2 terms in the denominator, you're going to multiply the numerator and the denominator by the conjugate. But before we even get into this, let me do one that does not even have a binomial. So let's example 1 in our dividing. So I want to divide this. I don't want this I here. If it's just I, you're just going to multiply by exactly what's in your denominator. Since it's just an I, whatever I multiply in the numerator, I multiply in the denominator. Now this is a binomial, so I will need to distribute that I. I times 2 is 2i. I times I is I squared. Over I times I, which is I squared. So now remember I squared is negative 1, so we have 2i plus negative 1. I'm going to go, over negative 1. Let's go ahead and split these up. So this is 2i over negative 1 plus negative 1 over negative 1. Remember, you're supposed to write this in the form of a plus bi, so the real number here is supposed to come first. Negative 1 divided by negative 1 is a positive 1. And here 2 divided by negative 1 is a negative 2. All right, let's do another example with just a monomial, which is one term in the denominator. So since there's no plus or minus in between the 2 and I, that's how I know that's a monomial. So you're going to multiply by exactly what's on there. Okay, now distribute. Negative 2 times 2 is negative 4i. Negative 2i times negative I is a positive 2i squared. Over negative 2i times negative 2i is 4i squared. Now replace your I squareds with a negative 1. Two times negative 1 is negative 2. 4 times negative 1 is negative 4. All right, let's split this up to make it easier to simplify. I was going to write plus negative 2 over negative 4. All right, negative 4. Well, let's do the real number first. Negative and a negative, first of all, that makes that a positive 2 over 4, which I can simplify by 2 to get 1/2. Here, negative 4 divided by negative 4 is a positive 1, so I don't need to write the 1, but I have that I. All right, now let's do some examples and see what happens when we divide by a binomial. So if there's like a plus in the denominator, and this is where the conjugates will come in. Something like that. Actually, let me start a little bit easier, and then we'll build up to that one. So you see how there's a minus here? This is how I know I need a conjugate. I will multiply that by the conjugate. Change that middle sign. Whatever I multiply in the denominator, I must do the exact same thing in the numerator. So now distribute. 13 times 5 is 65. 13 times 12, I think that's 156. Here I'm going to FOIL. 5 times 5 is 25. 5 times 12i is 60i. Negative 12 times 5 is negative 60i. And negative 12 times I is negative 144i squared. All right, so I have 65 plus 156i. Simplify the denominator. Those should cancel. That is the point of using a conjugate. Replace that I squared with negative 1. So I have 65 plus 156i over 25. Negative times negative is a positive 144. All right, now I just need to add the denominator 144 plus 25, which is 169. But then split this up to look like A over BI. So the real part comes first. And then this part comes after. These are really big numbers, but I know they can simplify because 13 goes into both of these. So simplify this by 13. You will get 5 over 13 here. 156 divided by 13 is 12. We saw that earlier. So it's 12 over 13i. All right, let's do another example where we have a binomial in the top and at the bottom. I'm not worried about the I on top, just in the denominator. So multiply. I'm going to go ahead and put parentheses here because these are all binomials. You are going to multiply the top and the bottom by the conjugate of the denominator, like that. Now we simplify. So 6 times I Let's erase that. 6 times I is 6. 6 times 1. 6 times I is negative 6I. Negative I times 1 is negative I. And negative I times negative I is a positive I squared. Do the same thing in the denominator. 1 times 1. 1 times negative I times 1. And I times negative I. All right, combine like terms, replace the I squareds with negative 1. So here I have 6. Negative 6I minus I is negative 7I plus I squared, which is negative 1. The middles should cancel, minus negative 1. So here I have 6 plus negative 1, that's a negative 5, minus 7I over 2. And then finally, you are going to split this up to look like that. Oh, I'm sorry. 6 plus negative 1 is not a negative, it's a positive. So that's supposed to be a positive. Okay, so that is how we divide. Multiply the numerator and the denominator by the conjugate of the denominator, and then you simplify. All right, the next thing we are going to do is we're going to do some simplifications of i's that have powers. Okay, so the goal is to change the power into I squared and then you simplify. So for example, if I asked you what is I to the 4th power? Well, I know I squared is negative 1. So I want to rewrite this in terms of I squared. But then I can't change the problem. So remember the product rule says you can multiply your exponent. So basically 2 times what would give me 4, and that's 2. So I squared squared is the same thing as saying I to the 4th, because you would do 2 times 2 to get that 4. Now replace your I squared with negative 1 squared. And negative 1 times negative 1 is a positive 1. All right, let's do another one. I to the 7th. So whenever it's an odd number, I can't make this an I squared. So if I put I squared here, 2 times nothing would give me 7. So I need to split this up first to make it an even number. So if I wanted to split it up, I could have I times I to the 6th power, because 6 i's plus another I would give me the 7, according to that product rule. This one was the power rule. So this I can't really do anything with, but I can rewrite I squared to the 6th power by putting a cube, because 2 times 3 is 6. So now I have I and then negative 1 to the 3rd power. Negative 1 to the 3rd power is negative 1, so this is negative I. All right, let's do another example. What if we add I to the 15th? And you can pause the video and try it. But what you want to do is split that up. That's I and then 14 i's left. So if I have 14 i's, this is the same thing as saying 2 times 7. That's a negative 1 to the 7th. Negative to any odd power will give you a negative. So it's like saying negative 1, which you get negative I. So that is how we simplify I powers. Okay, the other thing I want to go back to is solving the quadratic formulas whenever you get a square root that is negative. We never covered that before because we hadn't covered complex numbers, but now we're going to go ahead and do that. So let's say I have x squared plus 4 equals 0, and I want to solve that. You could use the square root method or you could use the quadratic formula. Honestly, it's probably easier to use the square root method, so let me do that. So you would subtract 4. You can only do that if it's only an x and a number. To undo a square, you can get the square root. Those are inverses of each other. So if I get the square root there, I get the square root here. Anytime you are solving and you are getting the square root, you must put a plus or minus. So I would put a plus or minus here, and then the square root of 4 is negative 4 is 2i. Because these conjugates come in, these complex numbers, when you're solving, they come in pairs. Now I could have done the quadratic formula here. If I was doing the quadratic formula, a is 1, b is 0 because there's nothing in front of the x, and c is 4. So negative 0 plus or minus b squared, remember the quadratic formula, for ac over 2a. So b squared minus 4 times a times c all over 2 times your a. 0 is nothing, so I don't need to include that. But I need my plus or minus. Here again, 0 is nothing. So I have a negative 4 times 1 times 4. That's a negative 16 over 2. The square root of negative 16 is 4i over 2. And you see this is the same thing as saying plus or minus 2i. All right, let's do one of these where we need to simplify our square root, so I can show you what to do when it's not a perfect square root. So if you try to factor something like this, you're not going to get an answer. So it's already in standard form, so I'm going to have a equals 1, b equals negative 6, c equals 13. Negative b, that's a negative 6. Negative 6 squared minus 4 times your a times your c. And this is all over 2 times your a. So it's going to be the same procedure, except we'll end up getting a negative. Negative 6 is 6. Simplify what's under your square root. It's 36 minus 13 times 4, which is 52. All right, now I need to do 36 minus 52, and that's where the negative portion comes in. Oh, that one wasn't as, I wanted a more difficult one. Okay, I'll have to do one more. Because I got negative 16, so the square root of negative 16 over 2. Let's go ahead and split this up. 6 over 2 plus or minus. Square root of negative 16 is 4i over 2. 6 divided by 2 is 3 plus or minus 2i. Or you could say 3 plus 2i and 3 minus 2i. That is another way of saying that. Okay. Let's do another one. Okay, so we have a is 1, b is negative 2, and c is 5. So now I have x equals negative b plus or minus the square root of b squared minus 4 times a times c. This is all over 2a. So that becomes x equals negative 2 is 2. That is 4. That's going to be 16 again. 4 minus 20. 2 plus or minus square root of negative 16 over 2. So that becomes 2 over 2 plus or minus 4i over 2. So this is the same thing as saying 1 plus or minus 2i, because 4 divided by 2 is 2. All right, our last example will be x squared plus x plus 1 equals 0. So A is 1, B is 1, C is 1. So x equals negative b. Remember the formula. So negative b plus or minus the square root of b squared minus 4 times a times c, and this is all over 2 times a. So we have negative 1 plus or minus the square root of 1 minus 4 over 2. Negative 1 plus or minus the square root of negative 3 over 2. When you have a negative, you can't leave your answer like that. An I needs to come out. So this would be negative 1 plus or minus I square root of 3 over 2. This is one way you could write your answer. You could also split them up. This is another way. Or I could just say negative 1/2 plus I square root of 3 over 2, especially if your homework is asking you to put a comma. Is then also another way. All right, so that wraps up our complex numbers, and we will continue with the next lesson at the next time.